These are some tips to remember IB chemistry functional groups and classes of compounds for a test, and I will also go over some naming examples of these compounds. So in total, there are 9 functional groups with 10 different classes, and the way I think about them is that I group them into pairs. So first are the NH2s, which are amidos and aminos, and then carbonyls, so these are ketone and aldehydes, since carbonyls is the big group. And number 3 are alkoxy and ester, so these are grouped together because the names of their classes are ether and ester, so very similar. And number 4 is carboxyl and hydroxyl, so they're the oxyls, and since they both have hydroxides in them. And lastly, they're just the 2 ones that are left, which are phenols and halogenos. And for the naming, we'll only have to know how to name alcohols, aldehydes, ketones, carboxylic acids, and halogen alkanes. These are the classes of compounds within the functional groups. I'll list out the suffixes for all of the groups, but you're only gonna have to know these main 4. Yeah. So first are amino and amido, which are you just have to remember that they're the ones with NH2s in them. And so amino first. So if you look at it, it says amino, and you can remember that no means no O. So it's just R, which is just whatever compound it's connected to, and to an NH2. And its class is just amine. You just take the O and switch it to an E. It's really simple, actually, compared to some of the other ones. And suffix, it's also amine, but you don't actually have to know that. Then amido, it says do instead of no. So you do add an O. And since you add an O, you also have to add a carbon atom to connect them through bonding. So it's going to be the NH2 with an O on a carbon connected to R. And its class is amide. So again, switch out the O for the E, and suffix is also amide. And next are carbonyls. So this is technically one functional group, but this is the only one with multiple classes that we have to know. So it has 2 different classes. And so first, if you look at the name carbonyl, you can find carb and O. So you already know, okay, so both of these are going to have carbon and an oxygen. And if we start with ketones, 1S, so you know that there's just one O with the C, and O with the C will always be double bonded because of oxygen's 6 valence electrons, so it will be bonded to 2 different R's, so they can be 2 different compounds, or they can be the same one, yeah. And the suffix is just 1 from ketone, so this is one that you will have to know how to name. And the other one, aldehydes, you're also going to have the carbon and the oxygen. But if you look at the name, you can find, it kind of sounds like add-hyde. So you have to add a hydrogen to the ketone, which means that one of the R's becomes an H. And the suffix is al. Al, it's going to be read ol, but it comes from the al of aldehyde. That's how I think about it. The third pair we will look at is alkoxyl and ester. And although the names of the functional groups don't sound very similar, the names of their classes of compounds are ether and ester. So that's really similar. That's how you can remember them. And for alkoxyl, alk is the name of the alkyl group of the R that will be bonded to the O. So if you take the prefix alk out of it, it just leaves oxyl, and oxyl is just O. So for alkoxyl, all you have to know is that there's an oxygen that's bonded to 2 other different or same compounds, and it belongs to the class of ethers, yeah. And the naming becomes kind of complicated because ether becomes the middle part of the word, and kind of depends a lot on what the R's are, so I've just excluded that since we don't actually have to know that. And the other one is ester. Ester is the only one where its functional group and its class of compound have the same name. And I think it's also the most complicated looking one. But how I remember it is that ester compared to ether, okay, ester has an S in it and it also ends with an R. So if you look at the shape of the compound, you can kind of see an S. I've drawn an S with an R at the end. But you also have to remember that there's an O on top. But yeah, this one just kind of has a weird shape, but it's really just carbon with 2 oxygens, and then instead of having a double bond, the oxygen bonds with another compound and with another R on the other side. So fourth pair is carboxyl and hydroxyl. So I think of these as the oxyls. They have OH them, so hydroxide, remember. And carboxyl, start with that. If you break down the word, it's carb plus O plus xol. So C, of course, is carb, O is oxygen, and xol is, I just think of it as hydroxide. So there's a carbon in the middle bonded to an oxygen and to a hydroxide ion. And its class is carboxylic acid, and the suffix is oic acid. And this one you do need to know. Next is hydroxyl. So hydroxyl, unlike carboxyl, it's a lot more simple. It just only has one hydroxide. Hydroxyl sounds really similar. So it's just an OH bonded to an R, and its class is alcohols, and you can kind of find the HOL in the word hydroxyl. That shows that it's alcohols. Its suffix ol comes from alcohol. And for, remember, for aldehydes, the suffix was al, and I just feel like they sound really similar in a lot of settings, like all and ol, so don't get mixed up with that. And lastly, the two functional groups left. They're halogeno and phenyl. I don't actually know if I'm saying these right, but halogeno is, you can think about it as halogen plus O, with the O meaning other. So don't add an oxygen to this, it's just other. So it's going to be R, whatever compound, bonded to a halogen, and it's usually just fluorine, chlorine, bromine, or iodine, as seen down here. The prefix would just be the first part of the halogen plus O. So fluorine would become fluoro, and then chloro, bromo, iodo. And its class belongs to halogen alkanes. And really, halogens, since they have 7 valence electrons, they usually form alkanes anyway. And I think these, they aren't part of the 4 that we learned that we would have to know how to name, but we did do a lot of practice with halogen alkane branches, so you do have to know them. And they're also pretty simple since they're usually just bonded to one halogen atom, yeah. And the last one left is phenyl. It's sometimes called benzene and is basically a ring. So it's a ring with carbons and hydrogens, and it's bonded to an R, so another compound. And the way I remember it, I feel like it has a really weird name. Its structure is also really different. So it's unlike the others, it's like an aromantic. But so that's how I remember the class is aromatics. Remember to drop the N though. And they're also called arenes, which I guess comes from phenyl also being called benzene. So that's the suffix that it's usually used. So that's all 10 classes of compounds and the 9 functional groups. And we can move on to looking at some of the naming, and I'm not going to go too in detail into like all the numbers and all that since it's really complicated. That part of this unit, you just have to keep practicing. You have to be familiar with everything for you to get good at it. But I'll do some of the more complicated examples so you can kind of see what it looks like. So the naming, how I start, I kind of break it down a lot because I don't want to get too confused. But first you have to count the longest carbon chain. And I think I always mess up a lot on this, but you have to make sure that you're not just counting the like longest branch in the middle. You have to make sure that you find the longest branch in the entire compound, which sometimes means you might curl up or curl down instead of being in a straight line. And so count all the carbons, find the longest carbon chain, and circle all of these carbons, especially if it's a skeletal structure. It'll make it a lot clearer. And find the correct prefix for your carbon chain. So like if there's 5, then find pent, and if you see any double or triple bonds, then change it to pentene or pentyne, otherwise it'll just be pentane, right? Then second, label the numbers, just count like the carbons 1, 2, 3, 4, 5, 6, and then decide which direction gives you the least numbers in the positioning of your branches. Third, circle and count each branch of compound separately. I think you can write the position and the name onto the compound, the picture of the compound, and then lastly write them into one alphabetically. It's just easier to break it down first before you have to put it all into one, and that also makes it less likely that you'll make a mistake. And remember that when you write them alphabetically, you're looking at the base of the word and you're ignoring the prefix. So, for example, if it's dichlor or something, then you would look at the C instead of the D to order that. Okay, so now we're going to look at an example. So, the first step would be to count my carbons. So, there's 1, 2, 3, 4, 5, 6. Since all of them are single bonds, I would find the prefix with 6, which is hex, and hexane, since it's an alkane. And next, I would count my carbons. So, as you can see, if I count 1, 2, 3, 4, 5, 6 this way, they would be on 2 and 3. If I did it the other way, they would be on 4 and 5. And since 2 and 3 is less, I will take 2 and 3. Now that we know the positioning of our branches, we have to list each individual branch. So our branches, there's 2 hydroxides here, and there's 1 bromine. And let's start with bromine since it's easier. So it's on 3, and there's only 1, so it's just 3 bromo. Remember, for halogenos, just add an O to the prefix of the halogen's name. So bromine would become bromo. And the other one, this one's more complicated. Okay, so now we have an OH group. And we think back, OH is an hydroxide. And remember, there was a group with just a hydroxide. It was a hydroxyl. And a hydroxyl, remember the HOL means that its class of compound is alcohol. And for alcohols, you take the last part of the word OL as your suffix. So here at positions 2 and 3, we have di, since there's 2 of them, and OL, since they're alcohols. So now that we have listed the 3 individual parts of this name, we have to list them alphabetically. But technically, only bromo would be a prefix, since for all other functional groups, remember, they all had suffixes. So for functional groups, it will go last after the name of the hydrocarbon chain. So in this case, 3-bromo would go first because 3-bromo is a halogeno group, which makes it a bit different, and then followed by the hexane, which is the hydrocarbon chain, and then you end with the suffix of 2, 3, deal. So that would be the name of this compound. Now let's look at a second example. All right, this one's slightly more complicated, but let's try to count our carbons again. So there's 1 carbon, 2, 3, 4, 5. So we see 5 carbons. Technically, there is a double bond, but because the double bond is inside another functional group, which we will determine which functional group this is later, it's technically still an alkane, and since they're 5, so we can start with pentane. Then we number carbons to see which way would result in less numbers. So there's a bunch of hydrogens here to confuse you, but that's part of the hydrocarbon chain. So actually, let's go back and let's circle all of the other branches first. So first, there is this OOH thing. The 2 hydrogens belong to the bond. There's a chlorine here, and then there's another chlorine here. And all the other ones are technically part of the hydrocarbon chain, so they are not branches. They're not branches of functional groups that we're looking for in the name. So now that we've circled these, we can tell that we have to order carbons starting from here. So 1, 2, 3, 4, and then 5. So again, let's start by naming these chlorines. We have 3, 4, and then dichloral. And now we have to figure out what this thing actually is. So we think back, which of our functional groups or classes of compounds had this structure? So if you look at the structure, that's an O and that's an OH. So remember we looked at a carboxyl. A carboxyl is a carbon plus an oxygen plus an hydroxide. So that would match this. And a carboxyl is a functional group. So the class of compound of a carboxyl is a carboxylic acid. acid. And remember that for carboxylic acids, the suffix is oic acid. So here we now know it's on position 1, which technically you just don't have to write that in the name, but we'll see that. And then it becomes oic acid. And so this suffix will be attached to the pentane. So again, as we've said before, the halogenos go first. So 3,4-dichloro, and then we directly write pentane. But now here, be careful because you have to attach the suffix of oic acid. And carboxylic acids can only be at the ends of carbon chains, but if it's at position 1, then you don't need to specify that. And if it's at position 5, here I would add a 5. But because it's in position 1, I can directly write pentanoic acid. And that would be the name of this compound. So basically, I just think that to get better at naming, you just have to do a lot of practice and you have to be ready to spot functional groups. And I'm not really sure how complicated the problems on the test are going to be, but just remember to break it down and carefully think about each part of the compound. So instead of being daunted by the entire compound as a whole, just look at it separately and identify the functional groups that you will know, because you'll have to know them. And I know you will know them on the test.